All right, we're going to take a minute and go through this annotation guidelines sheet. Remember that this sheet is linked on the home page of all of the architectural courses. So anytime you need to refer back to this, remember that it's there and don't hesitate to go through and read this thing. I realize it's not exciting reading, but there are some really important rules in here, and these actually do translate to most architectural offices. You're going to find a lot of similarities between the strategies we use to annotate a drawing and the strategies that you're going to find in most blueprints that you look at. Now, I will point out that the strategies are sort of geared around more of a commercial design type of a plan set. And when you're talking about residential plans, oftentimes the rules get a little bit looser, but the majority of the work that we're going to be doing out in industry is around commercial projects. So it's really important that you understand how these things need to be dimensioned, added notes, local and general notes, and all of the tags and other things that go in there. Let's start by talking about these general strategies. Remember who the annotations are for. It's easy to lose sight of the fact that these annotations are for the contractor. Now, the contractor needs to be able to understand what needs to be done, needs to be able to really easily tell how far things are spaced apart, exactly the sequence of construction and things like that. So this, just remember, it is a set of instructions for assembly of a building, not unlike furniture instructions that you get in stuff you have to put together yourself. Point number 2, consider how annotations will be used. Remember that this thing has to get built. And so giving information with the processes that are going to be used in construction is important, and I'll give you a few good examples of that as we get into the nuts and bolts of this. Number 3, try to answer every question a contractor might have. That includes things more than just dimensions. Of course, we have to dimension everything in our plans, but we also have to answer questions about methods and materials if those things are in question. Number 4, keep it neat, organized, and readable. It's really easy, especially on floor plans, when you start annotating, for the text and the symbols to overlap with the building geometry like walls and doors. So take the time that's necessary to adjust and move things around so that nothing is obscured. And number 5, always use the correct annotation styles. We're using the WDT ARC styles for all of our annotations. Your office that you work at someday is going to have their own styles that they're going to ask you to use. And it's important that we use them because every plan set that goes out of any particular office should look the same. It should look like the same person or group of people did it. Okay, let's go ahead and get into the meat of this thing. We're going to be talking about text first, and then we'll go ahead and address dimensions. And a lot of this discussion is centered around the document that we're going to have most of our annotations on, which happens to be the floor plan. So a lot of this is geared toward the floor plan, but some of the rules that we're going to be talking about can apply to other views like elevations, sections, and so forth. For text, all of the text and notes are going to be sized at 3/32 of an inch printed. Now, back in the olden days, that meant we had to do calculations on how big the text, or excuse me, what scale we were going to print it out at, and then we would have to downsize or upsize the text accordingly so it came out to 3/32 when it was printed. Fortunately, AutoCAD several years ago came out with a plan to automatically size that text. We just have to remember how it works. So in AutoCAD, and I'm just going to jump to AutoCAD real quick to talk about this, when we draw in model space, everything we draw is actual size, except for the annotations. Those need to be sized either up or down so that when we shrink that actual size drawing down onto a piece of paper, the text is still readable and it's at the correct size. The way we do that in AutoCAD is we use automatic scaling, which is through annotative text. And our text style is what drives that. So we need to make sure that anytime we're going to annotate a drawing, we want to go in and set these text styles to the correct one. Now, we're not going to use this annotative one. We're going to use either WDT ARC 332 or WDT ARC 316. You can already tell 332 is going to be the one we use most often. The other thing we need to make sure that we do is we set our scale in model space accordingly. So if we're going to be printing our floor plan at 1/4 inch equals a foot, we set that before we ever start creating text or dimensions. So we'll just go ahead and set those other two things. With the dimension, there is only one dimension style, so we don't have to make a choice there. And let me just loop back around to this discussion. 332 is if we want it to print at 330 seconds, which most of the time, 99% of the time we do. There are rare occasions where we're going to use a larger text size, 3/16 of an inch, and that's just for room labels and the like. Text scaling really doesn't come into effect because we use the automatic text scaling now. We don't have to do the math. We don't have to understand what the drawing scale factor is. But if you're ever working on a legacy drawing where everything in model space was sized manually, that is how they did it. So basically, if you're going to print at 3/30 seconds of an inch, the drawing scale factor for that particular scale is 48. So everything would have to be downsized, upsized by a factor of 48. Let me just back that up for a minute. If we want the text to print at 3/30 seconds at a 1/4 inch scale, which the drawing scale factor is 48 for that, we would take 3/30 seconds of an inch times 48 equals 4.5 inches. So that's the actual size in model space that we would normally have to create that text at. But since it scales automatically, it's going to do that for us. We're going to demonstrate that now. So I'm in model space and I'm just going to go ahead and create some text. I'm going to create my text box and I'm just going to type that out there. And I'm going to come in here and I'm going to use the measure tool to see how big that is. We'll just use this distance. And I'm going to get it pretty close. It may not be exact, but I'm going to go from the top of the text to the bottom of the text. And there it is. You can see that I'm really close to 4.5 inches. If I had something to snap to, it would be exactly 4.5 inches. Okay, so that's happening for us automatically. The only thing we have to remember is set the scale before you start annotating and pick the correct text style. So there that is down here at the bottom. Annotative text styles scale automatically based on the current model space scale, and I should say also the text style that you chose. All right, let's talk a little bit about dimensioning now. I do have a couple examples pulled up and we'll take a look at those intermittently as we go through this. Number 1, dimensioning exterior elements only, things you can see from the outside of the house. Now we're starting with the exterior floor plan dimensions, okay? So this is just related to floor plans and we're just talking about those dimensions that go on the outside of the house. This is a little bit difficult for a lot of folks to sort of grasp early on, but let's just go ahead and take a look at this. I'm gonna actually pull up this one right here. You can see that all of these dimensions around the outside of the house, these are all considered exterior dimensions. These are referencing only things you can see from the outside of the house. So for example, the corners of the house, anytime the outside footprint changes direction, we're going to put a dimension on that in both directions. Windows and doors, those are also seen from the outside. So those would be dimensioned as well. Now, there are some cases, we're going to look at some exceptions, like this window right here. You notice there's no dimension on there, but it's really obvious by looking at this that it's centered in this short wall right here. So the contractor is going to look at that and see that it's centered and a dimension is not necessary. In fact, it's better if you don't put a dimension on the things that you don't need to, rather than confuse the issue and clutter up the drawing. Most of the other doors and windows are dimensioned, including the garage doors. So we're going to dimension all of those things to the center of the opening. The reason we dimension the center of the opening is because we let the door and window schedule drive the size of the opening. So we're always going to dimension openings in walls to their center point. The next point on exterior floor plan dimensions is the dimensions run from the outside face of the stud walls and the center of doors and windows. So we already talked about the second one, but the stud walls we're dimensioning from where the lumber is going to go, and we're going to those outside corners. Number 3, dimensions run in continuous strings for the full length of the structure on all sides. All right, let's take a look at that again. So if we start along the top here, you can see that the first dimension string is just really hitting everything. It's starting on this outside corner of the garage, and it comes across and picks up this corner, all of the individual windows across the back, and then it terminates on the outside corner of the other side of the house. This side has a continuous dimension string all the way across. They're all lined up perfectly, and then a dimension above that is the overall dimension. So we're always going to terminate with an overall dimension. That's true even if it's redundant, even if that same dimension is on the opposite side of the house, which it is. We're still going to put it over there. We're going to make it easy for the contractor to there. They don't have to scroll around or look on another part of the page. It's all right where they're looking. They can see that very easily. The same thing you'll see is true on the sides. We're hitting everything with the first dimension string. With the second dimension string, we're going to see that rule come up in a minute. That's picking up major chunks like the width of the house, major jogs, and then the outer one, again, it's going to be all the way from one corner down to the farthest corner on the opposite side. Dimension line spacing, number 4 here, we're going to place the first dimension string at a distance of 1 inch from the house printed. Now that gets a little bit confusing because we need to understand how big 1 inch is going to be on the paper versus how big 1 inch is in model space. Again, we're going back to that drawing scale factor. We need to understand how that ratio between the scale on the paper and the scale in the real world, that ratio relates to one another. Subsequent dimension strings are 3/8 of an inch apart from each other. Unfortunately, in AutoCAD, there's not an automatic way to make those gaps happen. So let me just first let me show what it is I'm talking about with those gaps. I'm talking about the distance from the house right here to the first dimension string, this dimension line. That, when it's printed out, should be 1 inch. So let's work through the math on how that works. Remember that all scales are actually ratios. Unfortunately, we're using 2 different unit types. We're using inches and feet when we say 1/4 inch equals 1 foot. So we have to convert the feet to inches, and then we get a true ratio. So if we say 1/4 inch equals a foot, another way of saying that is 1/4 inch equals 12 inches, right? So now we have the same units on both sides. We can convert that to a ratio. How many times does 1/4 go into 12? If you guessed 48, you're correct. So the drawing scale factor for a 1/4 inch scale is 48, which means that if we take that 1 inch that we want it to be gapped when we're printing it, we have to multiply that by the drawing scale factor, in this case 48. So what we end up with actually is our first dimension string is going to be 4 feet or 48 inches away from the house. So that one was kind of easy. The other one maybe is a little more difficult. We're talking about 3/8 of an inch now, and it won't go back to that drawing. Hold on. There we go. Space subsequent dimension strings 3/8 of an inch. Well, that one gets a little bit harder, but we can still work that out, right? So 3/8 times 48. If you have a calculator that does fractions, that's pretty easy. But if you don't, you have to convert that fraction to a decimal first, 3 divided by 8. So the way that works is 3 divided by 8 equals 0.375, and then we multiply that times the drawing scale factor, times 48 equals 18 inches. Okay, so we know that that next gap is 18 inches between this dimension line and the next one. These ones are also 18 inches apart. Now you could just commit that to memory if you want. We have 48 inches to the first dimension line and 18 inches for subsequent gaps between dimension lines for any drawing that we're dimensioning at a 1/4 inch scale. Don't hesitate to rewind that and listen to it again. That's a pretty important piece of all of this. It's probably the more complicated piece in terms of you have to do math and you have to get a calculator sometimes. So yeah, back that one up and listen to it again if you're not sure you understood it. Moving on, multiple dimension strings. You can see that all of those dimensions on the outside of the house had multiple strings. So what do we include in each one? What kind of strategy do we use to put those on there? Well, I kind of gave it away earlier on. First string includes everything. Everything you can see. Edges of walls, windows, doors, anything else that you can see from the outside of the house. So all of that gets included on the first string. What I mean by the first string is this one that's closest to the house, all the way around. You'll notice that there's nothing that we're picking up on there that can't be seen from the outside, and there's nothing that we're missing that can be seen from the outside on that first string. The second string is going to include building jogs. So you could kind of think of that as overall dimensions at an intermediate level, right? So when you think about the width of major chunks of the house, we're going to include that in the second string. Let's take a look at that. So you can see that this second string goes all the way from the corner down to this corner, and that's 26 feet. We do that again down here. From this corner down to this corner, that's 24 feet. And then the third string, of course, is always the overall. Now, we do have one additional jog right here. This is kind of a special condition right here that there are a few different ways that we could do that. Let me just kind of show you zoomed in a little bit. This extra jog here, you might say, well, should this 24 feet include that 2 feet? I say no, because it gives the overall length of this wall, which is more useful to the contractor than including that jog in that overall dimension. So anyway, there are some gray areas in here. We can't always be 100% the same every time we do it, and one person to the next might interpret things differently. Don't worry about that too much. If you get the major points figured out, you're going to be just fine. And then the last thing we want to say, and these rules, these A, B, and C, help you to avoid this rule. Do not cross a dimension line with an extension line. If all of our dimensions for the small dimensions are the closest to the house, we won't cross a dimension line with an extension line. Let's go back and take a look at what that looks like. If all of these 3 dimensions across the side of the garage were out here and the 24-foot dimension was in here, we'd have all kinds of extension lines crossing over this dimension line, which is why we build outward with increasing dimension sizes. The 24-foot dimension can't cross a dimension line because it's aligned with the extension line of the smaller dimensions. That's not the case when you have the smaller dimensions on the outside. So that's why we sort of build it this way. Don't confuse that rule with extension lines crossing other extension lines. That is okay. That's not a problem, and the reason it's not a problem is because we have hash marks that are easy to read, and these can just kind of be followed all the way in. If you've ever seen a drawing that has dimension lines crossed by extension lines, you would know what I'm talking about. It does get very hard to read, and it can be very confusing and cause mistakes, especially to the contractor. Okay, so those are all the rules for exterior floor plan dimensions. Not too many, hopefully easy enough to understand. So next we're going to switch to interior dimensions for a floor plan. Those are a little bit trickier, and they're also a little bit more open to interpretation. Exterior dimensions, if the whole class dimensioned it correctly, 90% of it would look exactly the same, probably more than 90%. Interior dimensions, everybody's is going to be a little bit different. Hopefully we can come up with some rules that encompass what we're trying to achieve with that, and everybody can at least comply with those rules, even if they don't all look exactly the same. All right, so let's go through this list. We're going to dimension interior elements only, which includes primarily walls, but not only walls. Sometimes we have to dimension other things like, for example, a kitchen island, right? If we have a counter that's out in the floor, we need to make sure that the contractor knows where we want that placed, because it could really go anywhere. Here's an example of that. We have a kitchen island right here, and even though the island itself isn't dimensioned, we can assume that the cabinets that are going to be used to create that island are already going to be selected and picked out. So we just need to know where this thing needs to be placed on the floor. And as you can see here, we're going 4 feet over from the start of the edge, and then we're going 4 feet out from the face of this closet wall right here. So that should be enough for a contractor to place that thing right where it needs to go. All of the other interior dimensions really primarily are referencing walls. You can see that there is a string coming across here, and we're picking up this wall right here and where it's supposed to go left to right. This wall right here, also how far it is from the first wall, and we just keep going across all the way down. You can see we're picking up this closet wall, there's a pantry wall right here, and then we terminate out here at the end of the house. So we'll go through some more of these rules real quick. Provide sufficient dimensions so the contractor doesn't have to guess. It's impossible to have a perfect set of plans, but with dimensions, we really want to make sure that we scour the floor plan especially, and make sure that every single wall's position should be indicated on there. Now, I'm not talking about necessarily the length of the wall, because that is sort of defined by the walls that run in the opposite direction, those perpendicular walls. We'll take a look at that in just a minute. So we're going to be running dimensions both horizontally and vertically through our floor to pick up those horizontal and vertical walls. I'm going to hop down to the fourth bullet point. This really should be moved up in the hierarchy a bit because it's one of the more important aspects of dimensioning interior dimensions. We're going to extend dimensions in continuous strings extending across the entire house in both directions. Let me show you what I mean by that. You'll notice that these dimensions aren't just randomly scattered everywhere individually. They are organized in continuous strings that are aligned with one another, and they pass all the way through the house. Now, that's not to say we won't have an individual dimension here and there. This is an example right here. This 6-foot dimension showing the length of this wall. It wouldn't make sense to run that string all the way through because we've already got another dimension doing that, going this direction. So every once in a while when we get done with a string, we might have 1 or 2 stray dimensions we have to add in there. But for the most part, the rule is when you create a dimension, try to place it in a location that will allow you to continue all the way through the house. The contractor, when they lay these walls out, they're basically standing on a blank platform. The first walls they're going to put up are probably the exterior walls, but before they do that, they might want to mark where all these interior walls are. So they're going to drop their tape measure on the edge of the platform. They're going to drag it out and they're going to mark, 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 mark. And so if we give them a continuous dimension string all in one location that's easy to find and easy to read, that's going to make their job a lot easier. Same thing in the other direction. You can see that we're starting down here. It starts and ends on the exterior part of the wall, but we're going to mark, 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 mark all of the walls that the dimension crosses along the way. We'll backtrack just a bit to number 3. Keep dimensions organized and aligned to the extent possible. Organized and aligned really ties in with this continuous strings thing. Those two things are kind of staying the same thing, but moreover, let's make sure that we are doing this so that they stay readable and easy to find. Number 5, minimize the distance between objects and their dimension lines. So in other words, keep extension lines short. Whoops, I just closed that. There we go. All right, so as we look at this thing, you'll notice that the extension lines, this one is maybe a little on the long side, but what I'm talking about is if we were running a dimension string, say across down here, we wouldn't want to use the dimension string down here to tell the contractor where this island is. We wouldn't want to reach all the way across the drawing with our extension line to indicate where this is at. Number 1, he's got his tape measure down here. And so telling him that this island is 4 feet from this wall when you're running a dimension string down here isn't really all that useful to him or her. And so the other thing is we're running lines across the interior of our house, which just adds ink to the paper and it adds clutter and confusion. So it sort of takes up space that we don't need to take up. So keep your extension lines relatively short. Put another way, keep your dimension lines close to the objects that they're measuring. Number 6, on the main and upper floors, start interior dimensions at the exterior face of the exterior wall framing. I've been kind of indicating that as we go through this, that that's what we're doing. You can see that the dimension line is going to start at the exterior side of the wall. The reason, of course, is that that's where the contractor is typically going to hook their tape measure when they lay this thing out. So it just makes more sense to start it there rather than the inside of the wall, which is something that they're probably going to have to just subtract the thickness of the wall. So any dimension that they pull out, they're going to have to subtract 5.5 inches for the thickness of that. So let's not make them do that. We're always going to start and end our dimension strings at the exterior face of the exterior of the house. So what about the other hash marks? You'll notice that we're not dimensioning to the center of the wall. We're dimensioning, in this case, to the left side of the wall. And so you might ask the question reasonably, well, why not the right side of the wall? Why don't we dimension to the right? Why don't we dimension to the left and the right side of the wall, right? Well, the correct way to do it is left or right. Either one is correct as long as you're consistent. You'll notice that I chose left for this particular drawing. So every single dimension that's referencing a wall is terminating at the left side of the interior wall. The only exception is when we get to the end, now I'm on the right side of the wall because, again, that rule that we start and end at the exterior face of the exterior walls. So again, dimension to one side of the stud or the other and be consistent with your chosen method. Really doesn't matter which way you go. Now that we've instilled that in you, basements are a little bit different. Basements with concrete walls, we have to use a slightly different technique, as you can see here. So with basements for interior dimensions, we're going to start and terminate at the inside face of the concrete. Now, it might be obvious to you why we're doing that, but I'm going to say that anyway. We're going to start at the inside face of the concrete instead of the outside face because it would be really inconvenient to have to drill a hole through the concrete and put your tape measure in there to start your dimension. Of course, I'm joking, but that is why we do it. We're going to run that tape measure up against the concrete to lay out those wall locations. So interior dimensions in a basement where we have a concrete wall, we're going to start at the inside face and we're going to terminate at the inside face also. We're still following that same strategy, left or right, just be consistent. And this one really ought to be on the left side if the main floor is too. You want to be consistent across views and across sheets. And then the last rule, just avoid creating dimensions between objects that would be difficult to measure with a tape measure. Think about how the contractor is going to lay this thing out and try to take that into consideration when you're putting in dimensions. Okay, next section, standard features. This is talking about some features that don't require dimensions or labels because it's just too obvious. And whenever we don't have to put a dimension on, that's always a good thing, especially on a floor plan when there's just so much that's going to have to go on there anyway. We want to make sure that it doesn't get too cluttered up, too hard to look at. It's really easy to clutter up a drawing with stuff, especially at a smaller scale. So here are some things you don't have to dimension. Number one, doors and window sizes. So the doors and the windows are going to have a tag. Let's go ahead and take a look at what that looks like. You can see right here, this closet door has a little tag. It's a 5. This window right here has a tag. It's a B. Those are going to be keyed to a schedule, and the schedule is going to have all the information the contractor needs to order, install those things. And so that's just sort of like a little abbreviation, right? Keeps the drawing from getting too cluttered, too much text on there, and you're done. You don't have to dimension the opening. You also, and this is later on in the list, don't have to dimension its location in most cases. So in a situation like this where the door is centered in the opening, we don't need to have a dimension there showing where that door gets installed. It's obvious. The contractor is going to look at that and know immediately that goes right in the middle. We also don't have to dimension door openings that are adjacent to a wall. I'll show you what that means. If we look over here at door type number 6, you can see that the door jamb is a standard size. It's right against a wall. So all we have to do, really, the most we would have to do is call out in a general note what the minimum jamb size is going to be. The things that are going to drive that are the size of the trim mostly. Also, we need to be able to get at least 2 studs in there. So at a minimum, you're going to want those door jambs to be about 4 inches. But generally speaking, even if you don't draw it at exactly 4 inches, if you call it out someplace, the contractor will build it correctly. So one general note somewhere off to the side, down at the bottom in a general note column, or even a key note if we're talking about Revit, is sufficient on that. And if you look, most doors are installed right by a wall. They're going to open into a wall. You can see that most, if not all, of our swinging doors do that for the interior here. So we can easily get away with not creating dimensions at the locations of all those doors. We don't need to dimension the size, nor do we need to dimension the location. Again, door openings that are centered in a wall, such as a closet door, don't require a dimension. Let's go ahead and take a look at those. So you can see that all of these closet doors are centered. I put them in the center on purpose just for that reason. Usually when I'm cutting an opening for a closet door like this, I'll draw a line right from the midpoint of that inside line and then offset it out to create that opening at the size that I need. Not only does that oftentimes make the closet more functional, it also just makes it easier so I don't have to dimension where it is. Unless there's a compelling reason not to do that, that you want it offset one side or the other, it's usually just good practice to keep it in the middle. Number 4, the size of cabinetry. We might have a separate plan to show the layout of all the individual cabinets in a kitchen. Oftentimes for residential projects, that's going to be handled by the people that sell the cabinets. They're oftentimes going to supply their own plan with a key for each individual cabinet and where it's supposed to go within the kitchen. So usually we're not going to clutter up our floor plans. If the contractor does need something for the installation and it's not provided by the cabinet maker, a separate plan can be created at a larger scale to show that. So we're not going to dimension cabinet sizes. We're not going to dimension individual cabinet chunks, or where they start and stop, the dividing lines between cabinet pieces. None of that stuff needs to be done on a 1/4 inch scale floor plan. The wall thickness also does not need to be dimensioned. There are going to be some special conditions where the wall thickness changes and it's something that's very unconventional. But even when you're looking at the difference between a 2x4 and a 2x6 wall, the contractor generally knows that all of the interior partitions are going to be 2x4, with the exception of some plumbing walls and other things where we're going to have a 2x6 wall. But you can look at the plan and sort of make that out. Now, a lot of people will say that it's better just for safety's sake to indicate the 2x6 walls, or put in a general note that says something like, all interior partitions are 2x4 unless otherwise specified. In that situation, as a general note, you can put a local note just where the 2x6 plumbing walls are at. And then the last bullet point, closets and similarly small rooms don't require a room label if space is an issue and it's obvious what it is. So you'll notice that all of these rooms have these room labels in them, but even in this situation right here, it's not indicated that this is a bathroom. It's not indicated that this is a bathroom. We're not indicating this is a walk-in closet. But most people, especially contractors, are going to be able to look at this plan and see that's what it is without that label. So unnecessarily cluttering up the drawing with things like that is usually not a good idea. On the other hand, if it's a large enough space and there's plenty of room, why not do it? It just adds just a little bit more information as long as it's not cluttering things up. In some cases, it is appropriate to create a separate drawing of an area at a larger scale just to show the added detail or fit in the added annotations that are necessary to fully describe the space. All right, let's talk about notes and callouts next. There's only a few things in here we want to talk about. Number 1, room labels. Those should be placed in each major room, the exception of those ones we were just talking about, the smaller areas. Those are going to be at a larger size text. Okay, so we saw that previously. You can see the larger size text, that is a 3/16 inch text size, as opposed to all the other text. Local notes like this guardrail call out, the tags, the dimensions, local notes like this attic access pull down. Those are all 3/32, The only ones that we're going to use 3/16 for are the room labels. General notes and local notes, those are things that just require a little bit more definition, a little bit more explanation. A good example of that is this guardrail. It's not 100% clear without this note what's going on here. In fact, we might even say that there's going to be an enlarged detail of that guardrail showing exactly what it should look like. But at the very minimum on the floor plan, we should call that out just to indicate that that's not a wall. The wall ends here, and that guardrail sort of takes off and runs down to here. Another example on this particular plan is this little symbol right here. Now, a lot of people that have looked at this a lot probably understand that that is a pull-down attic access hatch. But calling it out specifically what it is, you could either put a tag on it and include it in the door schedule, or you can just give it a little general note. In a garage, it's generally plenty of room to add notes, so we're not really worried about cluttering things up in here. General notes are things that refer to the entire drawing. An example that we used earlier on general notes is the thickness of all of the interior partitions. We're going to use 2x4 framing for all the interior partitions. That would go in a general note, and general notes are typically going to be located, we don't have any on this particular drawing, but they would be located somewhere around the perimeter of the drawing or in an open space like this. We can certainly plant some general notes in there. If we look on the basement plan for this house, you can see down here there's a bunch of notes about the structure of the foundation. Those would be considered general notes. These ones with leaders that are pointing to specific components, those are your local notes. Appliances or other equipment that it's not readily obvious what those things are, we might put some abbreviations or even spell it out what it is. We also might, in situations where we have a lot of equipment, like in a commercial kitchen, we probably have some tags we're going to put on there, and those would be keyed to a schedule. So you can see in the laundry room here, it is important that the contractor knows where you want the washer and the dryer. So in this situation, what I've shown is a symbol showing a washer and then a symbol showing a dryer. Oftentimes you're just going to get a rectangle with a letter, a single letter in there, like W and D for washer and dryer. We might do something similar like in a utility room or a furnace room. This sort of, maybe it's obvious this is the furnace and this is the water heater, but it doesn't hurt in these situations to add just a single or a double letter, just indicating, making extra sure that they know where those things go. The reason placing those on the plan and making sure that they're labeled is important is because it does affect a lot of what the contractors do. For example, the washer and the dryer, well, the dryer is going to need an outlet, a special outlet, and special electricity going there for 220 volt appliance. The washer is going to need a couple of hose connections and a drain. So where those get placed is dependent on where you put them on the plan. Same thing is true for the water heater. Same thing is true for the furnace. You know, where that's going to be placed really is affected by where all those ducts are going to run, and a lot of the planning goes around that. The people that are designing the floor trusses, for example, they're going to need to know where that furnace is so that they know how to route those, how to design the ducts and the openings to allow for the, how to design the trusses to allow for the ducts to pass through them. Sometimes we show hidden lines for things that are either above or below the current view. And this would include things like vaulted ceilings, attic and crawl space openings, and things similar. So when we're indicating things like this is a vaulted ceiling out in the living room space. So we're going to indicate that with a hidden line. Well, if we didn't have this little indicator right here that says vault line, we might mistakenly think that that is the boundary, I don't know, between the tile and the carpet or something like that. So we need to make sure that it's clear what it is that we're pointing at. Similarly, we might have around this stair opening, we might have a half wall. Well, how is the contractor going to know that's a half wall as opposed to a full height wall unless we call it out? We might even hatch it in a special pattern just to indicate where that half wall starts and ends. Now this, to be clear, is not indicating a half wall, but if we had one there, if we wanted one there, we would have to call that out with a local note. Elevation markers aren't referring to usually anything on the floor plan, although there are cases where we're going to use those on the floor plan to indicate the height of things. but in most cases elevation markers are going to be found on sections or elevation views just to show the vertical distances between things, and we'll talk about those and demonstrate those in another discussion. Tags we've seen a bunch of already. Doors and windows can be tagged. Equipment, there are lots of things that can be tagged. Even walls, wall types. There might be multiple wall types in a building, and we might use tags to indicate those. Lots and lots of things that we use tags for, and always when we're going to tag something, there's going to be something that references somewhere else, and usually that's going to be a schedule with a lot more information. Sometimes those schedules are on the same sheet, and sometimes they're on their own sheet somewhere else in the plan set. And then finally, under the annotation category, callouts. When we have an enlarged detail someplace else in the plan set, we're going to have to call that out on the floor plan. Now, we don't really have any on this floor plan, but if we, for example, wanted to do an enlarged floor plan of just the kitchen to show all of the cabinetry, we would put a dotted line all the way around that area, and we call it out with a reference, something similar to this wall section call out, right? We have a detail number and a sheet number where that detail will be located. So callouts can be for enlarged details, they can be for section views, they can be for a number of different things. Usually it's going to be referencing a larger scale detail someplace else in the plan set. Okay, so some example, if you want a copy of the examples we've been looking at, those are linked in this document, and this document is linked on the home page, as I mentioned, of the course that you're in. So feel free to go out there and download those things. They will always be available to you through the courses that you take with me. However, it's not a bad idea just to have those handy and keep them nearby, someplace you can find them easily. I think most of the things I've been talking about are going to be pretty easy for you guys to work out. I did want to just do a quick demonstration of some of the things that are a little bit trickier in terms of how to add the annotations to a floor plan. So bear with me, we're just going to step through this slowly. You're not required to do this, but I do want you to really pay attention to how it's done, because at some point you are going to be asked to add dimensions and notes to a floor plan and other things, and you'll know how to do it much better if you're paying attention to this. Feel free to practice it though, you're just not required to turn anything in for this. Okay, let's go ahead and take a look at Design Center. We're going to bring in some blocks. Remember that tags are blocks. We're going to go ahead and pull one of those in. We're not going to fill it out necessarily, but we're going to pull in a door tag. We're going to pull in a window tag. Remember that these tags are annotative, okay? So you have to set the scale before you bring them in. Otherwise, they're going to be teeny tiny. You're not going to even be able to see them. We'll go ahead and bring in a section tag. And I'm not sure I need really anything else. Those are probably enough. Maybe we'll just bring in this call out tag also, just for fun. To demonstrate this. Okay, so a section tag, you'll recall that these are blocks that have some special capabilities, right? Not only do they have attributes, they also have some special grips on them. And you can see that this grip right here is going to flip the direction of this thing. This one can change its orientation, so we can flip it like that, spin it like that. We can double click on it if we want to edit the text in there, call out the call out detail number. We can stretch the length of the tail on that thing, and that's indicating that we're creating a section view of this particular area of the wall. We're cutting through that, and that's going to reference another drawing someplace else. The tags are much more straightforward. We're just going to place those right next to or near or inside or just someplace where it's unmistakable what it's referencing. And we have a separate tag for doors and windows, and all the doors, including bifolds and any other door that you have in your project, are going to be created for every door. Local notes are either going to use text or leaders, right? If it's pointing toward a specific thing and it's not 100% clear, just placing text next to it, what it's referencing, we'll use an M leader for that. Otherwise, we'll just use standard text, and both of those are going to be printed at 3/32 of an inch. All right, let's get to, we'll go ahead and do this too. I'm just going to bring this call out over and we're going to do a simulated call out for an enlarged kitchen, right? So with this, we can stretch this call out window. We're going to go ahead and move this up a little bit more like so, and then we'll stretch this down. So we just want to make sure that it encompasses the entire area that's being called out. We of course would reference the detail number and the sheet that it's referencing, wherever that is going to be located within our plan set. Okay, moving on to the fun stuff, let's go ahead and do some dimensions. Again, make sure that you set your dimension style first, and then you can create a dimension. Most of the dimensions that we're going to create are going to be using this linear dimension style, or this linear dimension tool rather. All right, so the part that is difficult about this is getting the gap set, and it's not really difficult, it just requires a specific technique. So I'm going to start at this corner right here, and my first dimension along this first dimension line is going to go to the center of this window, and so I'm going to pick this point, and now I need to space it. Remember we said 48 inches for a 1/4 inch scale, which is what I have my scale set to down here. We need to have that dimension line 48 inches out from this wall, okay? So what we need to do is acquire a point simply by hovering over a grip point. Now it doesn't really matter what grip point you acquire as long as it's on the outer face of this wall. So I'm going to grab the midpoint of this wall right here, and I have to get my cursor right on it to acquire it. Now you can see the tracking vector that's created from hovering. I need to be on that tracking vector, and now I can just type the distance, 48, and hit enter. So now that's exactly 48 inches away from the wall. If you're not sure that you did it right, we can come in here and just do a quick measurement between those two things, and it is indeed 4 feet. Now I can continue dimensioning across the entire rest of the wall. So the way I like to do that is just to switch over to the Annotate tab and use the Dim Continue option. You guys probably played around with that a little bit last semester with James. I'm just going to go ahead and click that, and it's going to pick up where I left off with that last dimension, and I can just go through and pick all of my next points, centers of all the windows. Sometimes it helps to zoom in just to make sure you're hitting them right. And then I'm going to terminate at the outside face of the wall, and then just hit enter when I'm done. Now I've got a continuous dimension string all the way across there, and you notice that I used the farthest projecting part of the house to set my 48 inch gap. So for the next dimension string, I'm going to again use a linear dimension, but this time I'm going to go all the way to the corner, and then I'm going to acquire the midpoint of this line, and then I'm going to use my tracking vector and type 18. Remember that was our next gap we were going to use, and now that gap is set. And if I'm not sure, I can go in here and measure that using just the distance command, and oh, that doesn't look quite right. Let me try that again in a different location. Distance from this point up to here, there it is, 1'6". I must have been on a different snap point. So that one looks good. Now I can go back to Annotate, say Dim Continue, and pick up this last leg over here. There's my second dimension string. My third dimension string is going to be the overall dimension, you'll recall. And so I'm going to go all the way from there over to here, and then I'm going to again acquire my tracking vector. I missed it for some reason. It's not showing up. Let me try the midpoint of this line. Sometimes it's easier to get away from other things. There it is. Now I can type 18 again and hit enter. All right. So if all of that was pretty easy for you, good job. We're going to do that on all 4 sides of the house. Here's a situation that you may not have considered. Sometimes we need an auxiliary dimension here and there, and that means basically that something that we're not going to be able to see from the outside of the house, like this right here. If I'm dimensioning this side of the house, this is not visible, and I don't want to pull a dimension line or an extension line through my house for an exterior dimension. So in those cases, I might need a dimension there, and I probably would also need a dimension right here as well, because I can't see that entire wall from this side over here or anywhere else. I'm going to go ahead and do one linear dimension on the inside of the house. So it really doesn't matter what point you pick for your first point as long as it's on the outside face of a wall. Then I'm going to come across and I need to pick some additional things. Now, the problem with this is I need to find a route through here that's pretty free of obstructions. So I'm going to just come in here, I'm going to choose the left side of my wall, and maybe I'll just pick the midpoint of this wall for my next point. And now I got to think about, and this is one of the reasons why I have a full-size cursor that goes all the way across, is I can look and see where I want this thing located that is a fairly clean path all the way across. And I think right here is pretty close. So I'm going to just pick this as my point. Now I can come in here, do dim continue, and I can just go through and pick the left side of the remaining walls. There aren't too many, just a couple more here. And then I'm going to terminate, as you know, on the outside face of the wall, and then hit enter when I'm done. Now these extension lines running through your walls, they're really not going to matter. If that bothers you, you can always grab the grip and pull it down closer. It's no longer associated with the wall, but it just doesn't have that long tail on there. But I promise you, you won't see those. The thickness of the magenta lines is much bigger, wider, thicker than the green lines are, so you're not even going to see those anyway. All right, so there's one interior dimension and one exterior set of dimensions on the outside. Hopefully that gets you where you need to go. That concludes our demonstration. If you have any questions or if I left anything out, don't hesitate to reach out, and have a great week, and we'll see you all next week in class.